remind you all that there will be a test. This, oh no, not this. Okay, so maybe next game, okay, because I didn't realize that this first you have that it means supposed to. So suppose there's no time. So I want to do a review all on this chapter before we have the test. Okay, yeah. So make sure everybody has on your table a copy of the worksheet. Yeah. So the new worksheet that your fellow classmates distribute. So. I want to do a review with you. Okay, yeah, and then the homework. You should have enough time to finish the homework. Yeah, so just pass it on, and then I'll collect from the some students later. Yeah, so you can pass it on the homework. And so all of you should have a copy of this worksheet, right? Yeah, thank you very much. Okay. Yeah, and so can you pick it out? We'll look at the some naming. Okay, on ionic compound and covalent compounds that we might discuss very briefly before. So on a new page on the notebook, okay, can you put down the naming of ionic and covalent compounds? Okay, so ionic compounds first. And how do we figure out the formula? So you see I created a table. Okay, so on the left, you find what we call monoatomic ions. Monoatomic ions are ions that contain just one atom. Okay, so first of all, ionic compounds, they are made of ions. Yeah, so made of the two types of ions. Yes. So ionic compounds are made of cations and anions. And both cations and anions can be monoatomic or polyatomic. Okay, so what does monoatomic mean? Monoatomic means they are ions that contain only one atom each. So you see in here, like Fe2 plus, Na plus. So all these ions, they contain one atom each. So we call them monoatomic ions. And then there's polyatomic ions. So you can put down ions can be monoatomic, and that could mean things like Na plus, Mg2 plus, Al3 plus. So don't be distracted by the charge. Okay, so what you see on the top right corner, those are the charge. The number of the atom can be found by reading the bottom number. And because you don't see any number here, that means there's only one of each. So therefore the term mono. So mono, the word mono describes the substrate. It doesn't describe the charge. Okay, so don't be fooled. Okay. It can also be anions. Okay, when you talk about monoatomic ions, like F minus, O2 minus, and 3 minus. So you see in these three cases, you have one. Okay, a number one that is not shown. So this would indicate that it is a monoatomic ion. So this is the first class of ions, say monoatomic ions. And then there are what we call polyatomic ions. So sadly, these you need to remember. So I ask you all to remember it, and because I know some of you haven't, so I have put it down for you. For your easy reference, you need to remember everything you see on this table. Okay. And by that I mean the name. For example, when you look over to the right side, do you see things like permanganate ion? Okay, so I expect you to associate permanganate with MnO4 minus. Okay, so ions can be polyatomic. Okay, so poly meaning it contains more than one atom each. So we are working on this one. So we are looking at this table. So ions can be polyatomic, like ammonium ion. So can anyone tell me how many atoms you see in a single ammonium ion, NH4 plus? How many? Remember, when you want to know the number, you read the bottom subscript. So how many total number of atoms do you see in in a single NH4 plus. There are 5. There's 1 N and there's 4 H's, right? So can you put down a description below? Each Na plus has 1 atom. Therefore monoatomic. But then in here, each NH4 plus has how many atoms? Has 1 N plus 4 H atoms. So that's what the numbers here 1 and 4 suggest. Okay? So that gives a total of 5 atoms per ammonium ion. So polyatomic. And then, this is where things get a little bit more complicated. You need to know the name. You cannot find the name of this ion from the periodic table because N4 plus has multiple atoms. So write down the name of it. We call it ammonium ion. And then we have also negative ions. Just like we can have negative ions for monatomic ions, we can also have negative ions for polyatomic ions. There are a lot. And I have grouped them by their charges for you. Okay? So you can of course scramble the order. But I think it's easier to remember the negative 1 charge as a group. And then the negative 2 charge ones as another group. And then the negative 1 as a single group. So you see, there are quite a few ions that has a -1 charge, including but not limited to nitrate. So this is nitrate. And then there's there's also hydroxide. Okay, so OH minus hydroxide. So the naming of ionic compound is easy because you just have to pick the ion from the above table and use crisscross rule. So you see down below, there's a gap I left between between these two tables. That's for you to put down the crisscross rule. I will use the first question here as an example to show you how we use crisscross rule. This will definitely be on the test next week. We don't have lesson this Thursday because of the event, so I'll delay the quiz to next week. But this will be on the test
Next week.
next week.
Next week.
Yes, next week. Okay. So mark it on your student handbook. Okay. Let's put down crisscross rule. So crisscross rule. You should know this very well now. We take the charge of one ion, let's say Na plus. We then take the charge of another ion, and then we swap the number. That's what crisscross rule means. Okay. Alternatively, okay, like some of the students approached me before and they asked, is there another way around this? Okay, yeah, we can also use the graphic method, right? Remember, Na plus sign means there's one depression, okay, and minus charge means there's a protrusion. So that way you can also work out the formula of NaCl to be Na1Cl1. So Na1Cl1 means for every one Na plus, you will need a Cl minus to complement it. You can't have them in a different ratio. Okay? So we will work on one more together, and the rest I want you to work quietly. Okay? I'll work on one of the polyatomic ion for you as well. Take ammonium phosphide as an example. Yeah, ammonium phosphide is just down below NaCl. So can anyone tell me what's the formula of ammonium ion? Either by looking at the table or from the memory, recall it from the memory. Ammonium is NH4 plus. Yeah, remember also the charge. Okay, so we will do NH4 plus here on the side. It is a polyatomic ion. You may want to write down the class of ion there. Monoatomic ions, they're very easy to figure out the charge. Just look up the group number. You see I created a table within a table here. And there's a table within a table. Because if you look up the group number of an element, and a metal from group 1 will form +1 charge. Group 2 will form +2. Group 3 will form +3. So these table within table you need to know. Monatomic ion is very easy to predict the charge. Just look up the group number. Na is group 1, so this is why it's 1 plus charge. Cl is group 7, this is why it's 1 minus charge. Okay, so you see here, -1 and +1. Okay, -1 and +1, group 1 and group 7. But ammonium ion, you cannot find its group number on the periodic table because it's not a single atom. And as such, you need to memorize the charge. NH4 1 plus. You see it here, NH4 1 plus. There's only one polyatomic ion that is positive with a 1 plus charge. Now, can you tell me what does phosphide mean? Which element is phosphide from?
PO4 3 minus.
Oh, that's phosphate. Okay, yeah. So this is why I want you to put down a few notes. A few ions I see students often mix up, okay? Like sulfate and sulfide, phosphate and phosphide, nitrate and nitride. Okay, so put down these three ions. They sound very similar, I know, but they are not the same thing, certainly. Okay, right now, the first one here, this is nitrate. It has a 1 minus charge. It is a polyatomic ion. This is nitride. It is a monoatomic ion with a 3 minus charge. Then we have another two confusing pairs. Sulfate, SO4 2 minus, and sulfide, S2 minus. Then we have phosphate, PO4 3 minus, and phosphide, P3 minus. Okay, let me give you a very handy rule. If you see IDE as the subscript, okay, more often than not it's a monoatomic ion, except hydroxide. Can you find hydroxide on here? Hydroxide is one of the polyatomic ions that also ends in IDE. But this is the only exception to the rule that says most ions, okay, most if not all, okay, except hydroxide, ending in IDE suffix, okay, so ending in the suffix IDE are monoatomic anion, okay? So that means they can only be monoatomic, these three, because they end in IDE, and therefore look up their group number. Okay, nitrogen is from group 5, so it's 3 minus. Sulfur is from group 6, so it's 2 minus. Phosphorus is again from group 5, so 3 minus. Okay, yeah, so these you need to, well, you don't have to remember the group number, but you do have to remember that something from group 5 would form a 3 minus charge ion. Group 6 will form 2 minus, etc. Okay, so now let's try this. Which ion should I couple to ammonium ion when I see the example ammonium phosphide? Should it be PO4 3 minus or P3 minus that I put next to this guy? When we say ammonium phosphide, P3 minus. Okay, so can you put P3 minus here and then swap the numbers around using the crisscross rule? Or remember I said if you like the visual method, you can do this. NH4 plus means it's an ion with a clet. Yeah, with a clet. P3 minus means it is a very large puzzle piece with 3 protrusion. How do you complete the puzzle? How many of each ion do you need?
3.
3 of?
3 of
among the NH4 plus, and just how many of P3 minus?
1.
Just 1. So therefore, making the formula NH4 bracket 3P. Okay, you can put down the 1 here. But remember the number 1 is not shown. So therefore, this example on the left would just be NaCl. And this example on the right would just be simplified as NH4P, NH4-3P. Okay, the number 1 is not shown. So now I'll give you all, to make sure that everybody here knows what we are doing. Okay, I want you all to work on the other questions in here. So we have not many actually. Okay, I'll give you the group number for the second one. So we'll work on this together. This will definitely be on the test. Okay, so if you have a question, raise your hand. I'll come to you now. Yeah, but the rest of the students, can you work on it quietly? Yeah, so I'll show you the periodic table. So I have, yeah, so you can find the group number here. So this is actually group 3 for DSE chemistry. So group 3, group, and then we have group 4, 5. So group 3, 4, 5, 6, 7, and 0 for DSE. Okay, for some reason this periodic table shows you other numbers. So can you now all work on the other examples? Yeah, I'll walk around to see if you have questions. Use it. What you need to do is to figure out the formula like we did, by either using the crisscross rule or the graphical method. Yeah, use either method to come up with the formula. Okay? So let me put down the second method in here. This is the I'll walk around. If you have a question, Rachel, I'll answer your question. So this is the graphical method. Use either of these methods to get to your answer. Your answer being the formula of the ionic compound. And yeah. You know what it is. For example, calcium oxide, you need to pick up the group number of calcium with group 2. Group 2 means 2 plus. Oxide means it's group 6. Okay, so it's -2. Yeah, or maybe you can take out a highlighter first. Take out a highlighter. You see there are some polyatomic ions, right? If you don't know which is monoatomic, which is polyatomic, it will be very difficult to work through this worksheet. So therefore, take a highlighter of your own liking. Okay, maybe you can use orange or I don't know, like maybe monoatomic, purple or maybe green for polyatomic. So what I want you to do now is with your two highlighters. Okay, do this. You have the first example, sodium chloride. Right? So sodium chloride, they are both monoatomic. That way, you know you have to look up the group number and then swap their charges. Okay, but for our first, for bottom example, ammonium phosphide. So ammonium phosphide. Which of these is polyatomic? Which of this is monoatomic?
Ammonium is polyatomic.
Yes, and phosphide is monoatomic. Phosphide. Okay, it's not phosphate. Okay, so that way you know you need to look up the group number. Because this is group 1, so therefore Na1 plus. Because this is group 7, so therefore Cl minus. Because this is group 5, what is the charge of something from group 5?
3 minus.
3 minus, so you put 3 minus. And ammonium, you can't figure out the charge yourself. You need to memorize it or use the table above. So there's nothing to like find out from the periodic table with polyatomic ion. You just have to remember the charge. Okay, so this is what you need to do for all of these. Take out the highlighter. If you don't have orange and green, it's okay. Just pick red or blue or yellow or any other color. Use the particular color for these ions. Okay. Yeah. Maybe one more so you see what is happening. Potassium carbonate. So which color should I use for potassium? Which color should I use for carbonate? Which of this is monoatomic? Which of this is polyatomic?
That's
Potassium is monoatomic, but carbonate is polyatomic. Because you see carbonate here, it is one of the polyatomic ion. Okay, so therefore, you know this is CO32 minus. And knowing that potassium is from group 1, what must the charge be for potassium if it is from group 1? What is the charge of something from group 1? 1 plus. Okay, 1 plus. So K plus. And then you need to do the crisscross rule thing here. So what is the formula of potassium carbonate then? When you swap the numbers around. K2. Yes, K2CO3. You don't have to write out the 1 because 1 is not shown. So this is what you need to do. Okay? Yeah, and for ammonium phosphide, we have NH4 plus, 1 plus, and P3 minus. So when you swap the numbers, you have NH4 bracket 3 P. Okay? Yeah, so I think highlighting it certainly helps. So I'll give you all maybe 2 minute hold. Yeah, okay. Oh, potassium is group 1. Oh, group 1. We are working on so Cn is 2 plus charge. Na is group 1, so it's N1 plus. So don't worry, you will have the periodic table and the exam if you don't need to look from it. Let me show you all the periodic table. If you don't have the periodic table on the practical, so if you want to access the periodic table real quick, you can go to ptable.com. Okay, like this web page here, very interactive. Okay, so it will show you like whether it's a metal or non-metal, obviously. Okay, so you see those lighting up here right now will be metal. These non-metals. So let's review the answer. So write down the answer, okay, on here because this will be on the test. For potassium dichromate, so potassium is group 1 again. So we do the same thing as before. So we have potassium, but dichromate, you find it on this table. Can you put a star around this table here? You have to memorize everything in here, both the name and the type. So when I say dichromate, I need to know that it's Cr2O7 minus. Okay, yeah, there's nothing to understand in here. It's just fact. Okay, it's just like everybody here has a name. Is there a reason why you have that name? No. Okay, it's just a name. Okay, so you have dichromate. So dichromate is polyatomic ion. So it has the formula Cr2O7 minus. So can anyone tell me what happens when I swap the numbers around? What is the formula of this compound? K2 Cr2O7. Good. Excellent. So this is potassium dichromate. The third box in the second row. The third box in the second row. Then we have copper 1 oxide. Okay, so you be careful when you see transition metals. Transition metals are the metals found in between group 2 and 3. Yeah, these ions, many of them can form variable charges. So can you take out a pencil and write down next to iron 2 plus, what we call iron 2 plus. We call it iron bracket Roman number 2. So can you put down this thing in here? Iron, let's take the bottom example in the third row. Iron 3 oxide. So when you see iron 3 oxide, what does that Roman number suggest? It is the charge of this transition metal. So iron is no ordinary metal. This is because it is found in between group 2 and 3. We call this special group of metal transition metal. Okay, they are unusual, so we are looking at this corner now. These are called transition metals in this form. They are unusual because they can form ions of more than one charges. Okay? Yeah, just like if there are two students in the same class who have the same name, let's say there are two Alex here, well then we have to call one Alex A, the other Alex B, right? In order to distinguish between them. Same here. We can't just call them both iron ions. Because if we just say the name of Alex, then two Alex will stand up. We don't know who we are referring to, right? So we need to distinguish between them. And as such, we need to use Roman numbers. So iron can form two ions, iron 3 plus and iron 2 plus. So when we address the name, we write it as iron 2 and iron 3. So therefore when you see iron 3, what does that mean? It is a iron ion with a 3 plus charge. What about oxygen? Which group is oxygen from?
6.
Group 6. So what is the charge of something from group 6?
2 minus.
2 minus. So when you put together, so you see practice makes perfect, right? So when you swap the numbers around, what do you get? Yes, Fe2O3. So I hear the answer. So it's pretty repetitive, I would say. Okay, so we'll check the answer for the rest right now. What about zinc sulfate? So zinc is 2 plus charge. You can find in here. So this is zinc. Okay. Some transition metal though they can only form one particular ion. Like for zinc, zinc can only form 2 plus. Silver can only form 1 plus. So therefore, when you see zinc sulfate, what does zinc sulfate mean? So what does sulfate mean first? It's SO4 2 minus, SO4 2 minus. It's on the table over here. Yeah. So therefore, you need to remember this by the weekend. You have one more weekend before the test. Okay. So you have zinc is 2 plus. So when you swap the numbers around, what do you have? Zinc is, well, normally you will write Cn2SO4 2, but remember we have to simplify the number whenever possible. So when we simplify the ratio 2 to 2, we get, 1 to 1. You know 2 to 2 means 1 to 1. So this can be further simplified as ZnSO4. Tricky, right? Yeah. So, but any volunteer for the last two questions? Aluminium permanganate. I'll give you the group number of aluminium. It's group 3. So what is the charge of something from group 3? 3 plus, okay. So what about the other ion, permanganate? It's 1 minus, okay. We saw permanganate some time ago actually. Well, no, okay, yeah. So I'll put it down, okay, still. So permanganate. It's on top. It's on top. You see permanganate is 1 minus MnO4 minus, okay. So permanganate is a polyatomic ion, so it's MnO4 minus. So any volunteer on the answer? Yes. Okay. AlMnO4 bracket 3. Okay. So AlMnO4 bracket 3. Yeah. And anyone have question on this? What about the last one? I really want an answer from the volunteer. Okay, I don't want to give you the answer directly. What about lithium sulfite? So you can find sulfite and sulfate. Mind the difference. They only differ in one letter. Okay, but then the formula is different. So lithium sulfite. I can tell you the group number of lithium though. It's group 1. That's all I can give you. So maybe we'll wait for 10 more seconds. I want maybe an answer from the audience. Lithium sulfite. Lithium is group 1. So Li2 SO3. Sulfite is SO3 2 minus. Yeah, so that's why I want you to mind the difference between sulfite and sulfate. Can you put down another example by the side, which is lithium sulfate? Okay, lithium sulfate. And yet one more example on the side, lithium sulfide. Okay, so if you think that they are all the same, you're wrong. Okay, they are all different. So lithium, of course, is always Li plus. But depending on what the other guy is, the formula is different. So what is sulfite? SO4 2 minus. What about sulfide? No, sulfide is a monoatomic ion because it ends in IDE, right? You see. Yeah, every time you see something ending in IDE, it's a monoatomic ion. So watch, this is I. So it's monoatomic. This is I. So it's monoatomic. And right now we have I again. So this is also monatomic. What is the charge of it if it's from group 6? S2 minus. So now all of you work on these three together. I want you to tell me what formula you will get when you swap the numbers around. We'll check the answer in 20 seconds. Okay? So swap the numbers around for all these. Tell me the formula of each. We'll check the answer in 20. Make sure you actually work on it. Don't wait for the answer. You should be working on it. On the test, you're on your own anyway. Okay. So do the cross here and tell me what the formula is at the end. Okay, so what's the answer for lithium sulfite? Li2? Yes, Li2SO3. What about lithium sulfate? Yes, Li2SO4. What about lithium sulfide? Yes, Li2S. So let me see, I'll just copy this one. Yeah, Li2S. So it's very clear. Okay? Yeah, so this will be on the test, so I want you to know clearly what to do, okay, in the exam when you see questions like this. Now, can you turn over to the opposite page, same page, opposite side, okay? We have covalent compound. So to find the formula of covalent compound, we use a slightly different strategy. We need to find what we call valency, okay? So what we are finding just now, what we were finding just now, these are called charges. Okay, so charges relate to how many electron an atom wants to gain or lose, okay, in order to become stable. For non-metal, we have the different story here, okay? We need to find valency. So covalent compounds and valency. So first of all, you may want to put this on a book because you may lose this page anyway. So valency for non-metal, of a non-metal is the number of electrons it needs to complete its outermost shell. To complete its outermost shell. Okay? Yes?
What does valency mean? What does valency mean?
This is the meaning of valency. Yeah, valency means it is the number of electrons an atom needs to complete its outermost shell. So to complete it. Remember what makes a complete outermost shell? For helium, how many electrons does helium need to have in its outermost shell? Helium will be 2, but for any other atoms, it will be 8. Okay? So when you want to complete your outermost shell, it will be 2 for hydrogen or helium, because hydrogen or helium, they have only one shell. And 8 for other atoms, because for any other atoms, they will have more than one shell. Okay, so other atoms than H or He. Yeah, so you can write down why only 2 for helium, because these two elements, these two atoms have only one shell. And the maximum limit for when you have one shell is 2 electrons. Okay? So these 2 electrons have only one shell. And all the other atoms, why do they need to have 8 electrons in the outermost shell? Because all the other atoms have more than one shell. Okay, so all other atoms have 2 or more shells, which have different maximum number of electrons allowed. So 2 or more shells. So therefore, this can hold 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then for hydrogen and helium, they can only put 2 because they have only one shell. The maximum limit for one shell is 2. Can you please wake up? We are working on the back page. Here, valency. Okay, so now let's try this. Finding valency. Okay, can you tell me what's the current electron arrangement of hydrogen? So hydrogen has an atomic number 1, which means the electron arrangement can only be 1. So can you write down 1 in here, or just draw a circle? Draw a circle here with just 1 electron, and put an H inside, and you can draw a set base on the side. It's said it is unstable because it doesn't have a full shell yet in its current electron configuration. So what is the closest noble gas electron arrangement? It will be like helium, right? So it wants to have 2 electrons to make itself stable. So how does it do that? Yeah, it's by sharing electron with another atom. So how many electrons does it need to complete its outermost shell? 2. From having 1 electron on its own to having 2, it needs 1. So the valency is 1. So you can put down it needs 1 more electron. Therefore, we say the valency is 1. because valency is the number of electrons it needs to complete its outermost shell. So now we'll do all of these together, don't worry, I'll walk you through. Okay, what about all group 5 element? Yeah, so all group 5 sounds like a very ambiguous statement. So you can write down nitrogen maybe. So group 5. So all group 5, e.g. nitrogen. Nitrogen has atomic number 7. So what's the electron arrangement? If you have 7 as the atomic number, what's the electron arrangement if you have 7 as the atomic number? 2, 5. So can you draw me the outermost shell of nitrogen? So this is nitrogen, and it has 1, 2, 3, 4, 5. So how many electrons is it away from having a full outermost shell? How many? 3. Yeah, 3. So therefore, before it can become stable, okay, it will need another 3 more electrons. Okay, so it will need 3 more electrons. So that's the valency of 3. That's what valency of 3 means. It needs 3 more. Okay, so it needs 3 more to make itself happy. Okay, I'm not computing the other 2 for you. You tell me the answer. What about the other group 6? Yeah, how many electrons? 2. Yes. What about group 7? Just 1. Okay. Yeah. So you can put down some examples though. Yeah. For group 5 we have nitrogen. For group 6 we have oxygen. For group 7 we have fluorine. So fluorine has atomic number 9, which means the electron arrangement of these atoms are respectively 2, 5, 2, 6, and 2, 7. So you can see how far 6 and 7 are from 8, right? So that's simple math. 6 is 2 from 8. 7 is 1 from 8. That makes them have valency of 2 and 1 respectively. So the valency of group 5 is 3, group 6 is 2, and group 7 is 1. Is that clear? Valency is how many you need to have before you become stable. So can you draw another 2 shell here? You can also draw a sad face here, showing that they are unstable. Yeah, and then we have a stable full shell at the bottom. Okay, so can you draw oxygen in here and fluorine in here and put back 6 and 7 respectively? Yeah, you see they are just 1 and 2 electron away, or I should say 2 and 1 electron away from being stable. So this is why their valency are 2 and 1 respectively. It says part clear what valency means. Okay, yeah, they won't ask you, well, so what is the meaning of the word valency? What is the literal meaning of it? No, we don't need to know the chemistry meaning of it. The chemistry meaning of it is how many electrons it needs to complete its outermost shell. Okay, so you have 1, 3, 2, 1 to remember. So now we have again a very simple practice below. Okay, so C and H. I'll try the first one for you. So we have what is the so use crisscross rule to work out the formula of the most common covalent compound. Okay, once the valency of non-metal unknown. Can you write down, maybe put this on a notebook? Between carbon and hydrogen, what kind of compound does it form? So you see carbon belongs to group 4, and hydrogen doesn't belong to any group. So how many electrons do they need to become stable for carbon?
4.
Yeah, 4. So therefore we say the valency of carbon is 4. And hydrogen, even though it doesn't belong to any group, what did we discuss earlier? Hydrogen has a valency of 1. So can you draw it like charge? But these are not charges, these are covalency. Okay? So you can put down what these numbers are. These are the valency of atoms. So you figure out the valency of the atoms and you cross them, just like you did, just like what you did. Can you tell me when you cross them, what do you get at the end? We have C, C1H4, which is CH4. So CH4, it should ring a bell. It is methane. Remember, methane is in the carbon fat, right? When they fat, they produce this greenhouse gas called methane. So we just completed one example. You know what? You can bring this further by drawing the CH4 molecule. So you have CH4 here. Remember, CH4 is basically a C surrounded by 4 H's. So you can then put, how many electrons should you put next to carbon? How many electrons belong to carbon? Carbon has an atomic number 6, which means the electron arrangement is 2, 4. So it can only have 4 electrons. Yeah, so 4, just 4. So we put 1, 2, 3, 4. What about hydrogen? Hydrogen has an atomic number 1, which means it can only have 1. So therefore, use these colors to help you. If you don't use color, you will just be lost in the many electrons in this diagram. You wouldn't know which comes from where. So you see, we successfully went from just 2 symbols to the formula of the compound to then the structure of the compound. So that's very little information we need to generate the structure. Okay, so now, can you all work on the second one together? What is the formula formed by the compound CO, C and O? Okay, so it's formed by the 2 elements C and O. So what is it? Can you simplify C2O4 further? C2O4 can be, 2 to 4 can be simplified further to CO2. All of you have heard of CO2, right? It's carbon dioxide. Okay, yeah, so let's write here. This is a trap I set, okay, yeah, because I know you would get C2O4. And I also want you to learn from this example that, so draw it side by side. So in your revision, it's just the same process. So C and O, carbon is from group 4, so the valency is 4. Oxygen is from group 6, so the valency is what? Something from group 6 has a valency of 2. So can you put C4 on C and then a power of 4, O and a power of 2, and you swap the numbers around. So what do you get when you swap the numbers around? Initially you get C2O4, but once you realize that these are ratio, so 2 to 4 can be simplified as 1 to 2, you will get to your next answer, CO2. So then now, can you show me the electron structure? We have to integrate everything we learn. They are not separate concepts. Like this drawing, they are connected, you see all these. So now I want your help. You have carbon with atomic number 6 again, it's boring, okay? Oxygen with atomic number 8. What's the electron arrangement of something with atomic number 8? 2, 6. So use the favorite color of your choosing. Yeah, draw me the diagram of CO2. Okay, yeah, we'll check the answer. This will also be on the test, not just the working of the formula. Yeah, this is microscopic world 1. Okay, yeah, so you have CO. We'll check the answer in a minute. Nobody in this lesson but you two. You can look around. SI is from group 4. CL is from group 7. Yeah, that means the valency are, 4 and 1.
How about sulfur?
Sulfur is group 6. Yeah, so you should. This is group 7. Yeah, and you already got the answer. Also draw the electron dot loss. let's check the answer. Okay, actually this was in the homework, if you remember.
Yes.
It was in the last homework, so if you have trouble working out, you know, you refer back to that one. So carbon has valency of 4. That means you can only put 4 dots in here. Or you can use cross, doesn't matter. Okay, I've just made up my mind and use blue to represent the electron for carbon. Then for each oxygen, there should be 6 crosses. So you have 1, 2, 3, 4, 5, 6. I put it this way because I want to ensure that all the atoms have a full shell containing how many electrons? 8. That's how you do it, okay? So you see, we just went from what? From just knowing 2 symbols. You see, I don't need to tell you much. I only have to tell you that you have C and O. And then you will be able to get to CO2, and then you will be able to get to this. We went from just the symbols to the formula, then to the structure. So write down what these are. These are just symbols of elements to the formula of the compound. To finally, the structure of the compound. So that's a lot. So structure of compound. So I will just work on one more with you, and the others you will work on it somewhat because it's taking too long. Okay. So what about another one? OF2. O and F. Sorry, I spelled on the answer. So O and F. What about O and F? So O is from group 6. So O is from group 6 and F is from group 7. So anyone can tell me the formula of this compound? OF2, yes. That's because if something is from group 6, the valency is 2. If something is from group 7, the valency is 1. So you have O with a 2 on top, 1 with F with a 1 on top. Then when you swap them, you get OF2. So now I give you all 30 seconds to draw out OF2. Okay? So you can put O at the center and F's on the 2 sides. I'll give you the atomic number of O and F. And you can always look at the periodic table on the textbook. So O has atomic number 8. F has atomic number 9. Which means that electron arrangements are 2, not 2, 8, 2, 6, and 2, 7. Yes. Make up your mind on which symbol to use for each element. We are checking the answer in 30 seconds. Can you write something? We are working on this. I don't want you to do poorly in the test. This is why I made you a sample, so you can cooperate. Okay, right, we'll check the answer now, okay, so you have O, there should be 6 dots, okay, so 1, 2, 3, 4, and then you have, so you have 1, 2, 3, 4, 5, 6, and then we have 1, 2, 3, 4, 5, 6, 7. Is this what you get?
Yes.
Yes, okay, so this is OF2, that's it. Okay. What about the naming of compounds? Okay, yeah. So we haven't yet talked about the naming of covalent compounds. We have talked plenty. Okay, about how we name ionic compounds, and this is how you name it. Okay. But then for covalent compound, we need to use these words. Okay. Write this on your note because I don't think I have it on the worksheet. Okay. Okay. So we have the naming of covalent compounds. So all you have heard of carbon dioxide, right?
Yes.
Yeah, so carbon dioxide has 1 C and 2 O. So when we name these like the 2 substances, these 2 elements in here, we will say carbon, and then we have di. So di means there are two oxygens. So we have dioxide. So what about other examples? I'll give you one more and see if you can find a pattern. See if you can see a pattern in here. So this is more complicated. P2O5. What is the name of the element with symbol P? Phosphorus. Phosphorus, yes. And O continues to be oxygen. So anyone can guess the name of this compound? Let me highlight something in yellow first. These numbers, you need to turn them into words. What is the English word for two? Di. So therefore we have di, write this down. So diphosphorus. What about a five-sided polygon you learn in math class? What do you call a five-sided polygon? Pentagon. Yeah, so therefore it is diphosphorus pentaoxide or pentoxide. It sounds like some kind of spell you see in a Harry Potter movie, but it's not. Okay, so you have diphosphorus pentoxide. And I'm sorry, there's a bit of English in here that you need to know. When you have two vowels sitting next to one another, you need to drop the A. So it's called pentoxide. Because it's difficult to pronounce two vowels together. Okay, so yeah, I'm not teaching you English, but you should know the A, I, O, U, their vowels. When you see two vowels next to one another, drop the A.
So there still is A in the spell.
No, it's pentoxide.
Okay.
Yeah, it's pentoxide. We'll have a few practice below, don't worry. But put this rule down, and I don't know how to explain to you like this part, but it's just a rule. So two vowels, okay, appear. If two vowels appear together, drop the first one. Okay, so drop the first one. So pentoxide. You don't have an A in the name there, so pentoxide. Now let's try another one. What about, so now I want you all to participate. What about N2O4? I'll let you guess. Okay, let me give you some hint first because it's too hard. I think without giving you any hints, I will tell you what English word to use for each number, and you should put this down. So you have we call this the prefix and the number. If you have 1, 2, not sure you can. Maybe yeah, you maybe will see. Wait, let me zoom in closely. So up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What are the prefix? They are mono. Yeah, you know when you hear people say monotonously, it means you don't hear any, like ups and downs in his voice. So you have mono, di, tri, tetra. Starting from 5, you should know this because you learned this in math class. Okay, in geometry class, you have penta, hexa, hepta, octa, octopus. Everybody knows octopus. 8 tentacles. Okay, nona, deca. That's it. Okay. Now I want your help. Okay. Tell me what's the name of N2O4. Remember this rule? Remember the vowel rule here? This is our English class, but you need to know this rule. You have N2O4. Yeah, let's do a warm-up example first. I still think this is too hard. Okay, what about SO3? That's not sodium. Sodium is Na. Sulfur, yes. Sulfur trioxide. Okay, so sulfur trioxide.
Do we not drop the I?
In this case, only if the vowel is A. Only if the first vowel is A do you need to draw it. Yeah, okay, I know. Okay, yeah. So here, because trioxide is not as difficult to pronounce as pentaoxide, you see. Pentaoxide. Pentaoxide, like, I don't know how you feel about this word, but yeah, trust me, I did not make up this rule. You only need to drop the A, you don't have to drop the I. Okay? Yeah, you only have to drop the A and drop the O, okay, as you will see. What about CO? So you all may have heard of CO from biology class. What is so bad about CO? Is it a gas that you can breathe without like any problem? You know, carbon monoxide can kill you.
Oh.
Yeah, so, and you just apply the rule when you call it carbon monoxide. You know you didn't call it carbon monoxide. Because when you call it monoxide, it's difficult to pronounce as there are two vowels next to one another. So let me clarify. You only drop the first vowel if it is A or O. You don't have to drop the vowel if it is I, okay? Yeah, so maybe let me put this in here. Yeah. So drop the first vowel if it is A or O, not when it is I. Okay, so this is why you still see I in here. So not when it is I. Okay, so now back to our most difficult example, N2O4.
Nitrogen trioxide.
4 is tetra,
Oh. Tetroxide.
tetroxide. Okay, yes. So put down dinitrogen tetroxide. Sounds like some kind of a spell, right? So tetroxide, drop the A.
So always can drop something from the previous
Oh,
one.
well, not always. Okay, not always. What about this one? What about CS2? What do you call CS2? Try this, everyone. Carbon. What do you use to describe number 2? Disulfide. Yeah, so therefore to answer your question, you don't always have to drop something. You don't have to drop anything in here. Okay, so can you write down carbon di? Yeah.
I mean, we're always dropping something only from the previous.
Yeah, only from the previous. You don't drop anything from the the name of that compound. Okay, yeah, from the name part. Okay, so disulfide. So carbon disulfide. Okay, some molecules have common name like H2O. I don't think you need to learn. I don't think you need to come to this class to know what H2O is called, right? But if you apply the rule you just learned right now, can you tell me what is the systematic name? Systematic name means you name it following a naming system. Okay, what would you have called H2O if you follow the same set of rules? Dihydrogen monoxide. Monoxide, yeah, so dihydrogen, can you write down dihydrogen? But we can call it more simply as, we can call it water, just water. So dihydrogen monoxide. And again, you are dropping the O from the mono. So therefore, you have dihydrogen monoxide, which is actually water. So some molecules have common names, just like you may have nicknames. Yeah, you have your name, but some people may also call you by your nickname. So the nickname of water is water. Okay, the systematic name. So you can put down. This is the systematic name, the official name, and yeah, it's dihydrogen monoxide, and this is the common name. We have many other examples of substances that have also common names, like Na3. Does anyone remember Na3 a while ago? It's ammonia. Ammonia, right? Remember ammonia? So this is right now the common name, ammonia. But if you really must call it by the systematic name, what do you call it?
Nitrogen
Nitrogen trihydride. Okay, so this would have been called nitrogen trihydride. I know it's hard, but this is why we should just call it ammonia then. Okay. Yeah. So other than ammonia and yeah. So this is it. And we have also CHCl3. This is chloroform. In those horror movies, I don't know what kind of movie is that, when people put a towel of chloroform on their mouth, and then you just black out. Okay, so that's chloroform. So, or maybe this is harder. Okay, yeah. So let's just write CCl4 then. Yeah. So CCl4. What would you have called this? So carbon. You see, they always end in I. So when you name covalent compound, there's something like that you should know. You always end them in I, no matter what. There's no eight. There's no eight. There's no I in the naming of covalent compound. There's only I. So this is also I, and maybe let me not use red there. Okay, so you can see I and I. Is that clear? That's a lot, right? To take in, but that's what will be on your test, unfortunately. Okay. Yeah. So can you finish the rest of the question here as well? Write down the name. Okay. Yeah. And oh wait, we have only 1 minute left. Okay. But then can you put down a placeholder on your notebook first? So it's the next chapter. We are done with microscopic world 1 officially, and that's a very straightforward. If you look at it, okay, book 1B. Okay, we will have a test on book 1B next week. Okay. So now will be. Anyone have any questions first? Before we move on.
All of book 1B.
All of book 1B is microscopic world 1, which is what we have just finished. Okay, we have discussed the properties of 3 different types of bonds, 4 different types of structures. What are the 3 types of bonds? Ionic, covalent, metallic bonds. But in terms of structures, there are 4 types. They are giant ionic structures, simple molecular substance, giant covalent structure, and the 4th and the last structure is giant metallic structure. Giant metallic structure. So you need to know their properties. Remember that worksheet I made for all of you. Yeah, this one. You'll be mine. Yeah, so can you all do a revision on this page? Okay? Yeah. So then we will when is the class? First 25.
40.
40, okay, then we will start a little bit of metal first. Okay, metal is the next chapter that we will look at. So metal. First, we look at how important metal is in everyday life. Put down some properties of metals that you should know. Okay, for example, it is like a ductile and malleable. So remember these 2 words. This may also appear in your microscopic world 1 test. Okay, remember ductile means they can be drawn into wires. Okay, so can be drawn to wires. And malleable means can be pressed or hammered into thin sheets. Okay, so pressed into thin sheets. Okay, so that's the first property. We have also other properties of metal, such as it being sonorous. Yeah, this may be a new word to you. Okay, but sonorous means they can make sound. Well, maybe you think, how is it a big deal? Okay, being able to make sound. Think about the church bell. Do you make the church bell out of wood? No, you make it out of metal. Okay, but brass. Okay, to be more specific, it's because it can make loud sound. Okay, when you hammer it. Okay. So sonorous means ability to make sound. Okay. So you can put down an example of everyday life object. Okay, that make use of this property, like the church bell. Yeah, and ductile and malleable. Anyone can think of use of something that can be pressed into or drawn to thin wires? Copper wire. Copper wire. You know, in electronic devices, yeah, in all kinds of electronic devices, there's copper wire. Okay. So you have to look at the circuit board before you know there are those wiring on it. So copper wire and gold foil on those fancy desserts, right? The gold foil. Okay. Well, most of those desserts still use imitate gold foil. They are not real gold foil anyway. Okay. But the real gold foil, you can actually eat it without any problem. Okay. What other properties of metal would be very useful? Okay. Well, the electrical conductivity. Do you know that the overhead cable, sometimes when you go hiking or do stuff like in wild, you see these overhead cables. They put between 2 very tall towers, right? Yeah, so these are the overhead cables. Do you know which type of metal is it made from? Aluminium, yeah. We use aluminium because of its lightness. Aluminium is so light that it made its way into, the making of aircraft. The last thing you want the aircraft to be is heavy, right? The passengers are already heavy, the luggage is already heavy. So it has to be made from titanium and aluminum. Both metals are known for their strength and lightweight, okay? So can you put down electrical conductivity? Okay, so therefore, for example, we have overhead power cables. They are of course made from metal, okay? So overhead power cable. Yeah, there are many, okay? They are also known for their good heat conductivity. So heat conductivity. So if you have a copper pan at home, okay, for boiling water, then or pot, copper pot, then you know copper is best known for its heat conductivity. They don't just conduct electricity well, they also conduct heat very well. Okay, so that makes metal extremely useful. But then there are some additional properties, okay, that are unique to some metals, okay, such as their lightweight, okay, so like special property of certain metal. So of certain, maybe the first one you don't consider as special power, but more like special weakness, okay, is that iron, when you expose iron to the air for quite some time, what will happen to it?
Rust.
It rusts. Yeah, so I would just call it property. I wouldn't call it superpower because it's super weak for iron to rust. So special property of certain, to put this last one down. Certain metals, we have number one, iron can rust when exposed to the elements. Okay, don't say elements in the exam. You have to be specific. It's oxygen and water. When I marked the Form 6 student paper, I still noticed that they wrote air and water. Air is not clear. Air is not specific. You have to say oxygen and water. If I would accept air as an answer, then you can just call these two air components. Yeah, you can't call it air and water. You have to say oxygen and water. So just write down this equation. Iron plus oxygen plus water equals rust. Okay, you will learn more about the formula of rust later. And just one more, titanium, okay, is light but very strong. So light but very strong. So we can use titanium to make some artificial hip joints. You know the old people when they have, let's say, some kind of accident, their old joints no longer work, then we can make new joints, okay, based on titanium. So we will continue with this next time, and next week test on 1B, microscopic world 1. Okay, don't know excuse for not having the textbook. Okay, yeah. So, yes. What day? When do you want? Thursday. Next Thursday. Okay. Right. So, yeah, review. And anyone haven't handed in the homework?